Karpaga Vinayaka, College of Engineering and Technology, Department of Electronics and Communication Engineering, Center of Academic Excellence, welcome you all to discuss on general solution of transmission line equation. Transmission line is a circuit with a distributed the parameter. In the transmission line, current and voltage vary at the every point. So to analyze the transmission line, we go for the general solution of transmission line. It provides the current and voltage at any point. Now consider the transmission line length L. The transmission is nothing but the D section of infinite number of D section, the uniformly distributed. Now consider this is the transmission line, this is the D section, it's a n number of the D section connected, it's called as a transmission line. Here the S denoted as the distance from the receiving end. Here the IS is the flow, the current. Here in this transmission line, the voltage drop considered as changing the voltage with respect of the distance is equal to I into Ez. It's a rewrite, it's called as a dE by ds equal to I into Ez. This is the equation 1. Similarly, consider the current. The vary the current with between the 2 points, it's with respect to the distance, the di divided by ds equal to E into y. It considers the equation 2. Now, the again equation 1 and 2 differentiate with respect to the s. Now we can obtain the equation d squared E divided by ds squared equal to z into di by ds. Like it's for the current. Now the both E and S are function of the S. So we can substitute this E di by ds value from the equation 2. So now we obtain the equation 3 and 4. The equation 3 and 4 are the second order differential equation. So already we know the general solution of the second order differential equation. We can rewrite this equal to E equal to A into E power root of y z into s plus b into e power minus root of z y into s. Like the current equal to this one, consider as the equation 7. Here we have to find out A, B, C, and D values. So to find the A, B, C value, now we consider that the distance S equal to 0. Now the substitute the S equal to 0 in the above equation 6 and 7. Now it's become ER equal to A plus B, IR equal to C plus D. Again, the differentiating the equation 6 and 7, we call the equation 6 is A into e power root zys. The differentiating with respect to yes, the answer is A into root of zy into e power root of zys. Like that here, this term we have to multiply with here. It's like that, it's considered for the current. Okay, now we already have the value for dE by ds. It's IEZ. The substitute here. Now the equation become IEZ equal to A into root of zy into e power root of zy in minus b into root of zy into e power of minus root zy into s. Okay, like it's considered for the voltage and current. Now consider the equation 9 and 10. From the equation 9, we find the I. So we have to divide the both side by z. So it's a divided by z, like that b divided by z. Now it's considered as the equation 11 and 12. Again now we substitute s equal to 0 in the equation 11 and 12. Now we get the IR and the ER values. Now we have to consider the equation 8 and 13. We have to multiply in both sides in the equation 8 root of y by z. We get like this. Now this added with the equation 13, the b term is eliminated. So only we have the a. So adding this two equation, we got 2a equal to this one. So from that we find the a. Similarly, we have to find the b, c, and d. We obtain the answer a, b, c, d. The a, b, c, d answer we have to substitute in the equation 11 and 12. We obtain the final equation of the transmission line. Again, we can reduce this one, taking the LCM of ZR and taking the ZR plus Z0 Zr is outside from the above equations. Now this equation, it's taking the outside, it becomes like this. Now again the Zr plus Zr multiply with the inside, we got this equation. Then again the individual e power root of yz multiply with the Zr and multiply with the Z null. So similarly here root of, e power root of zy S term multiply with the zr minus z null. So now here we have the fourth term 2 e power root of zy terms and the root e power minus. So we can rewrite like this to in change in terms of the sign and the cos. So here e power root of zys plus e power minus root zys divided by 2. We can rewrite this here cos. Like that here we can rewrite this by the sign heads. So it is the final equation of the transmission line. From this equation, we can find the voltage and current at a